So we're changing when our valves actually open and close. Engine will lack low speed power. So that goes back to what I mentioned earlier. When we change camshaft timing, we change when we make power. So we're lacking on the low end. Once we get the engine revved up some, power output's going to feel normal. So the same thing could happen if our timing belt starts to stretch, or if our timing belt jumps a tooth. We could have the same scenario. So with most timing chains, don't really have a regular maintenance interval for them. Timing chain is basically if it starts making noise, or if we start having a concern, then we'll go in there and diagnose it and repair it. And here's an example of timing gears. So you can see on this one, our cam is in the block, so overhead valve engine. And again, that's not used very regularly. Diesel engines are pretty much the one place where you may still see this. And here we have a timing chain on an overhead valve engine, so the cam is in the block. Any ideas what that is up front there? That's that eccentric. So on this one, the eccentric for the fuel pump, rather than being part of the cam, it just basically bolts right to the front of the cam. But we're still using the cam to ultimately drive the fuel pump. And this one would be the flat link or the roller, the flat link or the silent type chain. So use all those flat links, so this will be a fairly quiet one. Again, on these short chains, there's no tensioner typically. So the way we check this is just basically measure the amount of deflection or slack in that chain. So for this particular one, let's say 1/4 of an inch of movement is okay, 1/2 an inch is unacceptable, so we have to replace it. Realistically though, since most of our timing chains don't really have any sort of maintenance interval, if we're at a point in an engine repair process where this thing's staring us in the face, what are we most likely going to do with it? Probably going to replace it, right? And kind of hard to see the difference here, but this is the roller style chain. So it still has the flat links on the outside, but in between the flat links it has those cylindrical rollers. And again, it looks basically just like a bike chain. Most of these chains for automotive use, they're what they call a double roller. So again, it's hard to see in this picture, but it's basically 2 roller chains side to side. So 2 chains put together. So by putting 2 chains side to side, we get double the strength, right? And you can see on the sprocket, you have basically 2 sprockets, essentially 1 for each chain. So again, a little bit noisier design, but a little bit stronger as well. And here's an example of an engine where we have multiple chains. So we have 1 chain coming up to drive 1 camshaft, and then from that camshaft we have another short chain going over to drive our second cam on the cylinder head. And it's kind of hard to see, but in between here on this short little chain, here we have basically a little timing chain guide. There's going to be a little tensioner inside there as well to keep tension on that chain. And again, just as easily, this could be a timing belt coming up here driving 1 cam and then a chain driving the other. So we do have some engines that use some combinations of the different options.